Hello everybody, and welcome back to Knowledge on Ears. Take a look at this. We have a black arrow drawn on a piece of paper. When we put it behind the glass of water, it flips direction, it reverses. The arrow is pointing in the opposite direction. How does this happen? In this video, we will be covering the topic of refraction and how it happens. But before we do that, let's take a look at a few more examples. We have a charger. What will happen if we put it behind the glass of water? Once again, it changes direction. You can see that it just flips. How did this even happen? We will cover that in the video. Now we have a piece of paper with the word moon written on it. What will happen when you put it behind the glass of water? The word just flips around. It says noom, not moon. How does that even happen? Why is everything flipping over? This is because of refraction. Refraction will be covered in the later portion of this video, in the theory part. Another picture we have is a girl on a piece of paper. In this case, it does not refract. It just stays the same. This is because the girl is symmetrical, so there's nothing to flip around. How did that just happen? This arrow just changed direction. It just flipped. How did that just happen? Before we get into that, we're gonna just dive into a smaller, easier concept to understand the big picture. Take note that refraction of light is a very difficult concept, but today we're just going to be talking about the simple and easy basic ideas. So let's take a look at this. This is a division between water and air. We also have an imaginary line that's perpendicular to the surface called the normal line. Now let's say that we have a ray of light that's striking the surface of water. Now what will happen? Will it keep going straight or will it bend? What will really happen? To understand this, let's take a look at an example. So for you, is it easier to run through air or is it easier to run through water? I'm sure you guys will all say it's easier to run through air. But why is it like this? Well, in air, the particles are more spread out. Like this. This is air. But in water, the particles are closer together. Like this. So in water, particles are closer together. So when we're walking through air, there is very less resistance when we're walking, so we can easily walk through. But in water, there's more resistance, stopping us from walking, since water is more dense. So how does this affect the light? Well, light follows the same rules. When it travels through water, it's much more difficult for the light to travel through water because there is more resistance, so it slows down. And a very important rule is a change in speed is a change in direction. So, when the light slows down when it enters water, it actually changes direction. So since it bends closer towards this normal line. When light loses speed, it bends towards the normal line. When it gains speed, it bends away from the normal line. Since water has more resistance, it's losing speed. Now let's take a look at the actual scenario. Let's say that we have an arrow like this. Okay, so this is our arrow right here. Let's also say we have a cup of water, the one we used in our experiment. So if this is our cup of water, we have rays of light coming from an external source. In this case, let it be the sun, that's giving us the rays of light. So if we have rays of light, obviously there's more than two, but in this case we're going to use two to help demonstrate the scenario. We have two rays of light that are coming from the sun and are hitting this glass of water. Now, as we learned earlier, there's a change in speed when it enters this cup, so a change in direction. So in this case, if this is the normal line, it will bend closer towards the normal line, like this. So now it bent closer to the normal line. Now though, it's leaving this water and it's entering air once again. So this is the new normal line. Now what will happen? It's gaining speed, so it's going to bend away from the normal line. So in this case, it's going to bend like that. And here it's going to bend like this. So our new arrow will be formed right here. But why? If you look here, the end of the arrow comes up like this and comes over here, while the tip of the arrow comes all the way over here. So now the new arrow is like this. This is the new arrow, and it has flipped around because of all this bending of light. Refraction, the bending of light, is the main cause of how this happens. In our real world, refraction can be used for multiple things. The rainbows we see outside is created through refraction from water droplets. People that have glasses or contact lenses use the concept of refraction of helping them correct their vision. There's so many uses of refraction, and refraction is very important in our daily lives. Thank you for watching.